Alrighty, CNT125, Chapter 8, we're going to subnet a Class C network. So let's take everything we've reviewed to this point, our Chapter 3 addressing subnet masks, subnet fundamentals, all these pieces. Let's start to put them together now. Remember, all zeros in the host portion is network number. All ones in the host portion is broadcast address. If it's a mixture of ones and zeros, it's a usable address. This is what we want. We need those in some sort of chart or format that we know those are the addresses we can use, and we need to have the network numbers and the broadcast addresses kind of sorted out so we know not to use them. So we need really a table of the usable IP addresses. Alright, so we're going to do this kind of in chart form. It's the easiest way I know to do this so that we know which one's network, which one's broadcast, which one's usable. So let's take a Class C network and dig in. So a Class C network, we've been given a Class C network, a 220.45.35.0, and we need 6 subnets for maybe 6 different floors, 6 different wings, or 6 different types of devices, desktops, wireless, IP phones, printers, etc. Okay, so we start off with the 255.255.255.0. We start off with, here's our subnet mask in binary, and we need 6 subnets. Well, to get 6 subnets, if I borrow 1 bit, I'm going to get two network subnets. If I borrow 3 bits, I'm going to get, or excuse me, if I borrow 2 bits, I'm going to get 4 subnets. I'll get it yet. If I borrow 3 bits, I'm going to get 8 subnets. Well, 6 doesn't hit, but I need to go 1 larger to get it done. So if I borrow 3 bits right here, I will get 8 subnets. That'll be enough. I'll have 1 or 2 left over, okay, but I'll get what I need. So if I borrow 3 bits, I'm going to get 8 subnets. 2 to 3 bits borrowed gives me 8 subnets. And I'm going to have how many left? Well, if I take a look down here, here's my 3 bits borrowed. I'm going to be left with 5 bits in the host portion. So 2 to the 5 is going to give me 32 addresses per subnet, of which 30 are usable. That would be another piece I double check. Is that enough addresses for the IP phones? Is that enough addresses for the wireless? Is that enough addresses for the desktops? So that would be a double check I do. You know, doing this, I get 8 subnets of this. Are those 2 pieces going to work? I double check that before I go any further so I don't waste any more time. Let's say it is. I'm going to keep rolling then. I take my subnet mask and I'm going to alter it to have everything recognize that we've borrowed those 3 bits. There it is right there. So 255.255.255. I take this last octet, convert to decimal, and end up with 224. I also want my bit count. 8, 16, 24, 25, 26, 27. There's my 27 bits, so my bit count is /27, or my CIDR notation is /27. Now we have the pieces in place to actually start making this work. The easiest way I know to do this is looking at my subnet mask, 255.255.255.224 right here. Here's the last octet, 224. Since I borrowed 3 bits, that bit right here is called, some people call it the interesting bit. If I look at that interesting bit, that is actually the 32 place. So 128, 64, 32, that's the 32 place. My subnets are going to go up by a factor of 32. It is groups of 32. I'm literally going to take this Class C network and break it into 8 pieces of 32. That's what's going to happen. So, because if I go back here real quick, let me go back 1 page. I said I'm going to get 8 subnets of 32. Okay? So I see that by when I look at this right here, I've borrowed out to this place. That's the 32 place. I'm going up by a factor of 32. That is going to help me very quickly build the chart I need on the next page. So on the next page, I start with a chart. I always do the subnet number on the far left column. So I start off with every network's going to start with 0. The next one's going to be 32. The next one's going to be 64, 96. I'm going up by values of 32 until I reach 255. If I add 32 to this one, I'm going to get 256. So I know that's the last subnet. There's my 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 subnets. So those are going to be my subnet numbers. The other side of my chart, I'm going to put my broadcast numbers, my broadcast addresses. Okay, and to get that, if this one starts at 0 and this one starts at 32, this one up here has to end at 1 less, 31. It has to end at 1 less. So this is going to go 0 to 31, and if I count that, that is actually 32 numbers, isn't it? 0 to 31, if I count them up, is actually 32 numbers. This one right here is going to end at 63 because this one starts at 64. This one ends at 95 because this one starts at 96. This one ends at 127 because this one starts at 128, and I keep going until I get 255. There is my first range 0 to 31, next range 32 to 63, and so forth. So now I have a chart where it shows me my network numbers on the left, my broadcast numbers or broadcast addresses on the right. In the middle is going to be my usable addresses. And the usables will be one more and one less. I will go one more than the network number, which would be 1. One less than the broadcast, which would be 30. So my usables go from 1 to 30. Now, let me back up real quick. If you remember when we did our planning, we said we are going to have 8 subnets. That's the 8 rows that I have on my chart. They're going to be 32 big. Each one of those goes, first one from 0 to 31, which is 32 numbers. And then we also said there's going to be 30 usable. So if I go back now, here's my 30 usable in the middle. Because I got rid of the network number I can't use, and I got rid of the broadcast address I can't use, I'm left with 30 usable numbers in the middle. So all my planning is panning out here when I put it in a chart like so. And all I need to do is continue through 32, this is 33 to 62 because the broadcast is 63. 64, 65 to 94 because broadcast is 95. 96, 97 to 126 is 127, and so forth. There is my chart of subnet, usable, and broadcast addresses. And if I go back to my planning, I find out that I have 3 bits barred. I get 8 subnets. There they are. 1, 2, 3, 4, 5, 6, 7, 8. And I said there's 5 bits left. I'm going to get 32 addresses per subnet, of which 30 are usable. Here they are. Boom, 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 boom. 1 to 30, 33 to 62, and so forth. There is my planning panning out for me, and now I have a chart of numbers that I can actually apply. And we will do that. In lab, we will do that. We're going to do some of these problems first. Then we're going to turn around and take our numbers and start applying them to routers and workstations and see them work. That's when things really click for me. So hang in there. We're actually going to apply these to routers and switches and nodes in the network and see it all work. But now that I have this, I can actually make my map and plug my numbers in and make them happen. If I were to use a subnet calculator, yes, there's applications out there called subnet calculators, and plug this information in, I actually plug in the IP address here and I plug in the subnet mask. I have to do that so it knows. When I do that, I get, boom, here is the actual breakout of the 8 subnets of 32. And you'll notice it actually shows the whole IP. I've only been focusing on the octet where things happen. If you notice, I've only been focusing on this last octet out here. And this subnet calculator is a good reminder that it really is the whole IP. 220.45.35.0, 224.45.35.32, okay? So these IP addresses would be in this subnet right here. These IP addresses here would be in this subnet here, and so forth. And now I could say, okay, this subnet is going to go to the first floor of my building, this subnet is going to go to the second floor of my building, this subnet is going to go to my third floor of my building, and so forth. Or assign them by department or wing or whatever. There is what subnetting a Class C network looks like. I'll come back in the next one and look at subnetting a Class B.